Hello everyone, my name is Phoenix and in this video we are going to solve an QuillCTF challenge which is gate. Let's see what the objective of CTF is. You need to set the open flag to true via the open function and handwrite the bytecode opcode and stay within the less than 33 bytes. Alright, so there is an interface that we have been provided. There are two functions here and then there is a contract. So for the ease, I will just copy all of this into my local development environment. Now let's see. There is a contract called gate and the bool is opened. So there is only one function in this whole contract that just takes address of the guardian contract whose interface is provided and check these three require conditions. The first one is that it should be within the boundaries of 33 bytes. The second one is the condition that if this function is called, it should return address dot this, and tx.origin should be returned if this one function is called. The last one is that ABI encode when the fail function in the guardian contract should return to when called. And if all of the conditions are successfully done, then our bool will be switched to true. So this contract requires you to create a bytecode from scratch to bypass all of these activities. To shorten that process, I am gonna explain you with the help of a walkthrough. So for those of you who have a little to no knowledge of EVM bytecodes, I would highly recommend you to check this article by Knox, Deep Dives into a Coder, and then the 13th chapter of Mastering Ethereum, where they have talked about Ethereum virtual machine. I believe after reading these two addresses, you will be able to make sense of what is happening. And so let's just directly jump to the test contract. We have created a great variable that sets up a new contract. Now, the tricky part is that you have to specify chain ID to 1 in order to be within the boundaries of 33 bytes. Then this whole function is being used through this library of ssstore. So what this function does is you provide the hex code and it will generate the creation code for you that is responsible for successfully creating the the executing contract, and then you'll sort of use the create opcode for providing the address. So in order to simplify the process, let's see the function signatures of these two functions first. So what I'm going to do is I'm going to visit the website called function selector calculator, and I'm going to put this function selector function to see what selector just gives. Interestingly, it's all zeros, and for the second one it's 1. So the names of these functions are carefully crafted to make the results as 0 and 1, and this information is important for us to sort of figure out what sort of data we have to manipulate while creating a set of opcodes. We will just go to the runtime.txt file where you can get all the opcodes that is being used to do this. So in order to understand more about opcodes, you can visit the website called Ethereum opcodes, and you'll be able to understand each and every opcode that is being used. So for example, Call data size and call value just checks the amount of value and call data from the environment. The push 0x1c is pushing the 28 bytes, because first if you convert this 0x1c hex into decimal, you will get 28. And since one stack size is 32 bytes and the first 4 bytes are reserved for the function signature, the data that we have to push is 28 bytes, which comes down to 0x1c. Then we have some copies, mloads, chain ID that we have specified as 1. And in order to understand it in more details, let us just walk through what the answer, the explainer text is saying, that in order to be within the values of 33 bytes, you have to use call value instead of push one, so that instead of occupying 1 byte, only occupying 2 bytes, you only get to occupy 1 byte only. The function selectors of 0 and 1 are carefully crafted, as I have said. The last challenge, where it's saying that when you call the file function, it should return false. The explainer has created an overflow EVM error so that this conditions just bypass, because a low level condition doesn't have assertions that you get at a higher level, just like using save transfer from than using transfer from. The main reason to do that is because save transfer just asserts the value as true. Now, for the test file, what we are going to do is we'll set up a new gate, then we'll apply chain ID as 1. Normally in Foundry, the chain ID is not 1, it's I think 222337, I don't know the exact value. Then we just deploy the gate exploit, which is the address. We'll assert 2. The deploy exploit functions work like this. This is the function that we have already visited in this file, that lets you create a contract code with the bytecode. The bytecode we have already figured out. We'll pass that into, and if all of the conditions are true, I think forged rest will also pass. Let's see how it goes. As you can see, the test has been passed. That means our capture the flag solution was right. This marks the end of the video. Stay tuned for the next CTF challenges solutions. Thank you.